Hello, everyone. Thank you for coming. Today, we'll be talking to you about how we're leveraging multimodal LLMs to build Shopify's global product catalog. My name is Ali. I'll be walking you through this with my colleagues, Audrey, Jonathan, and Young. Millions of merchants are using Shopify to sell billions of products around the world. They're selling to millions of customers in every continent of the globe. As merchants create more and more products, it emphasizes the importance of product discovery more and more. Products are really can really be seen as a fundamental unit of commerce. They're really what connects the merchants to the buyers. And without world-class product discovery, we are leaving a lot of opportunity on the table for both our merchants and the buyers. So at Shopify, we've made it crucial and a focus area for us to deliver world-class product discovery so that our merchants can focus on what they do best, being entrepreneurs, and allow us to help them build bridges with their customers. So why is this an important area and a focus area for us? See, Shopify makes it really easy to start a business. All you really need is an internet connection. But the more merchants join Shopify and the more products they create, we already have billions of products being sold on our platform, the harder it becomes to discover and retrieve products. So the importance of product discovery is scaling at a similar rate that we're scaling our platform. If we don't deliver world-class product discovery, what could end up happening is what you see on the left-hand side. We have a very siloed experience. Every merchant is an island on their own, even though they're all on our shared platform. And the customers or the buyers will also have a very fragmented shopping or a journey on our platform, which is not good for anyone. And that's why we built Shopify's a global product catalog. The catalog aims to unify product information across our platform, across the merchants and the different shops that are hosted on our platform. With this unification delivered by the catalog, we unlock a lot of opportunity. We first have optimized product discovery, but it doesn't stop there. The catalog allows us to tackle next generational commerce use cases, things like shopping AI assistants, for example, or VR for commerce, or even generative recommenders that we talked about in the last NeurIPS 2024. Cool. So why is this problem difficult? Why is it hard to build a unified product understanding at Shopify's scale? As I said, Shopify makes it really easy to start a business. Here on the slide, I'm showing the product creation page that you have in the admin. And as you can see, it's pretty much free form. You can put whatever title you want, whatever description, upload images, have different options for your product. So there's really very little restrictions on how you create and design your product and how you sell it in your store. While this is great and makes the barrier to entry very small, it also creates challenges. There's this heterogeneity because of that free form. As you can imagine, there's going to be data quality problems, data entry problems as well, carried over with that freedom that we allow. Shopify also has merchants in every continent in the world, which means we have a multilingual problem. Like we need to understand the different languages when we're doing this unification. And it's not hard to imagine that with millions of merchants, there's going to be products that are being a single product could be sold by multiple merchants, like a soccer ball or an iPhone 15, for example, can be sold again and again by different merchants. And we need to understand that these different products are the same, even though they're being sold by different shops. The the inherent structure of products, where a certain product can have multiple variants, also creates a challenge, right? So if I want to understand that the two products being sold by different merchants are the same, they could be available with different variants at the different shops. So all these together hopefully motivates in your mind that this problem becomes difficult, and the difficulty increases as our scale increases as well. Cool. So just to give you a 10,000 view of what we have built, this chart illustrates where the catalog sits in Shopify's ecosystem. So our merchants are building their stores on top of our Shopify platform, leveraging our infra. On top of that, there is the catalog layer, which we're viewing as a foundation of foundations. The catalog unifies product information, and on top of it, we're building two main things. One is the commerce foundation model, as I said, that we spoke about at New Reps last year. And also, we have our AI assistants. The AI assistants, you can one important example is Sidekick, which we released to all merchants last year. It's the assistant that helps merchants navigate the admin. And on the other side, the commerce foundation model enables us to unlock many cases in different surfaces, like in the shop app, the storefronts, even in the admin. Use cases like recommendations, personalization, and search. So all of these foundational pieces are being built and leveraging the catalog. To highlight this point, I picked both recommendation and assistant to give you an idea how we're leveraging the catalog. So in the recommendation side, our generative recommender is trained on a large vocabulary of products. And we're starting to leverage the catalog to enhance how our generative recommender represents products. Instead of thinking of products independently without factoring in the context, we now leverage artifacts from the catalog to improve the representation. For instance, here I searched for my favorite soccer ball in the shop app, the Adidas Tango Glider. And as you can see in this picture alone, that this same product is sold by at least 8 different merchants. So for the recommender system to be intelligent, the way we're representing products is in our embedding, we have a portion that's contributed by the catalog. So here for this Tango ball, we'll have a portion in the embedding that represents the cluster where all these balls sold by different merchants belong. So you can imagine how this representation will be more contextual for us. On the other side, for assistants, we noticed that where we have the exact same products, but with a little bit of variation in the descriptions, that can really trip AI assistant. This is an example here where we have the exact same book, same universal ID, but two different merchants described it slightly differently. And without the catalog, we noticed that assistants can really get tripped there and think that they are different products. So hopefully these two examples motivate in your mind the importance of that unification product understanding layer. Cool. All right. So hopefully by now you understand the why we're doing this. And next, we're going to go in more detail. So first, Audrey is going to walk you through the architectural picture of what we built. After that, Jonathan is going to do a deep dive into the technical details and the implementation. And last but not least, Young will talk about the impact that this is having inside Shopify and also some future directions. So without further ado, Audrey, please walk us through the architecture.
All right. So let me walk you through the architecture of our global catalog system. At its core, we're tackling a fascinating challenge. As mentioned, how do we create a unified understanding of products when they're listed by millions of merchants, each with their own way of describing and presenting their items? Our system consists of 4 main layers. Let's start with the foundation, our product data layer. This is where we handle the raw complexity of e-commerce data. The second layer is what we call our product understanding layer. This is where the real magic happens. We've implemented a series of multimodal LLMs that help us standardize and enrich product information. This is where we handle the creation of simplified titles and descriptions, image analysis, attribute extraction, and more. The third layer handles product matching. This is where we solve the entity resolution problem, identifying when multiple merchants are selling the same product. Finally, we have our reconciliation layer, where we bring everything together. When we identify the same product across multiple listings, we create a canonical representation that aggregates all available metadata. This includes incorporating review summarizations, which capture product quality, key characteristics, and seller information. And the output of these four layers are then integrated into Shopify's various systems, for instance, search. First, let's dive deeper into our product data layer, which forms the foundation of our entire catalog system. Here, we're dealing with what I call the three V's of e-commerce data: variety, volume, and volatility. To start, let's talk about variety. Our ingestion pipelines handle product data, each with their own uh, individual description. We're processing data from multiple input sources, merchant uploads, but also APIs and third-party integrations, which means we can get data in different formats and with different added components such as HTML embedded content. Uh, our inputs are also unstructured, which means one merchant might give us a novel worth of product description, while another might just provide a title and a price. Additionally, we provide a lot of flexibility for merchants to define their products in a way that works for their storefront. So one great example is Shopify's product options. So what that means is, products are sold under different options, like a hoodie might come in different sizes or different colors. And we give merchants the flexibility to not only define their option values as they like, but also their uh, their option keys. For example, instead of having a color attribute for a watch, a merchant may have a dial color and a band color. As a result, key metadata that are required in order to sell items across multiple channels or that would help them make them more discoverable are either missing or inconsistent. The volume aspect is equally challenging. We process over 10 million product updates daily, which requires a distributed streaming architecture. And we've implemented a custom schema evolution system that maintains backward compatibility while allowing for dynamic attribute expansion. Uh, this means merchants can innovate in how they describe their products without breaking existing systems. The volatility aspect is also important because data isn't static. Descriptions get updated and new attributes emerge as products evolve, and our system handles these updates in real time while maintaining data consistency. Uh, the end result is a foundation that can handle the messiness of real-world e-commerce data while maintaining the structure needed for our more sophisticated processing layers. So next, let's discuss our product understanding layer. Here, I'll give a broad overview of the kind of tasks that we're looking to perform. So we tackle multiple challenges at this step, categorizing products into hierarchical categories according to a predefined taxonomy. We perform attribute extraction, where we identify key features, extract colors, size, materials, etc., and detect brand names and models. We perform image understanding. We also perform text generation tasks like title standardization. A merchant may want to put all variant information inside of a title. So iPhone 16 Pro 256 gigabyte silver is quite long. And so we might want to condense to just iPhone 16 while preserving the variant information and attributes. We also perform description analysis, summarizing product descriptions and extracting key selling points. And we'll also do the same with reviews, which provides us an overview of the quality of the product. And currently, we structure all of these as a multitask, multi-entity problem. So I will explain how this works by focusing on three key entities: media, products, and variants. Each entity represents a different grain of the catalog. Products can contain multiple product variants. For example, a hoodie that comes in multiple colors and sizes. Uh, each product and variant can contain multiple images. Other example of entities could be like the seller and reviews. We fine-tune small open source vision language models to perform multiple tasks simultaneously and for each entity. For media analysis, for example, we've implemented a specialized model that extracts key visual attributes. Our model doesn't just identify color, it extracts precise hex codes and also performs image quality assessment, uh, evaluating factors like composition, lighting, and professional appeal to give an overall image quality score. And similarly, for product and variant analysis, we're both performing classification and text summarization tasks. Um, uh, Category classification informs attribute extraction, and extracted attributes refine classification decisions. Furthermore, visual features complement textual understanding. This multitask approach not only improves efficiency, but enhances accuracy through shared learning across tasks. What we find is that with multimodal LLMs, performing these tasks simultaneously actually improve the performance of each individual task. Um, our taxonomy system represents a crucial component of product understanding. So, the taxonomy itself started as an extension of Google's products taxonomy, but we've transformed it into an open source system, which allows merchants to tell us exactly how their products are evolving. However, beyond this, we are also leveraging LLMs to suggest taxonomy expansions. So our system will identify patterns in product listings that don't quite fit existing categories, suggesting new nodes or attributes that might be needed. And the right side shows how attributes are intrinsically linked to taxonomy nodes. This is crucial because different product categories require different attribute sets. This bidirectional relationship between taxonomy and attributes form the backbone of our product understanding system, which enables consistent classification while maintaining flexibility. And the output of this. So after we've gathered all this relevant product metadata, we have our product matching layer, which solves the fundamental entity resolution problem in e-commerce, identifying when different merchants are selling the same products. So the core architecture for our entity resolution process uses a multi-stage approach. Our first stage focuses on candidate generation through a few parallel approaches. Our first stage creates fuzzy matches, and not all connections are equally reliable. A shared GTIN, which is a product barcode, is more trustworthy than a similar product title or something you might get from embedding similarity. Um, so in our second stage, we've implemented a cascade of discriminator models to validate these matches. So that can include first pass filtering using embedding distance thresholds, XGBoost models that consider multiple features, including category and attributes that we may have extracted at our first step, um, and specialized validators for specific product categories. The system maintains high precision through this edge pruning, which happens when we apply the discriminator to these initial candidates. Um, Products form the left hand. So we model this as a bidirectional graph where products form the left hand nodes and the various linking features and candidate matches form the attributes on the right hand side. We then compute connected components on this graph, and which provides the initial product clusters to which we assign a universal product ID. Once we've identified products that are the same through our matching system, we face a new challenge. How do we create a single authoritative representation when we have multiple potentially conflicting sources of information? And this is what our reconciliation layer solves. One merchant may provide more details than another merchant. So in our first layer, even if it's very accurate, we may be missing certain attributes. So when different listings provide complementary information, we merge technical specifications, we combine product descriptions, and aggregate and summarize review content. Here we also use LLMs to perform this work. This enhances the product representation, which is useful for various downstream use cases. So let me show you how this unified product understanding system drives real value across Shopify's system. We've deployed these enriched product representations in three key areas. First and most critically, we feed these insights directly back to merchants as they create listings. We provide real-time recommendations during product creation, instantly suggesting accurate categories and proactively identifying missing attributes. This helps merchants create more complete, standardized listings from the start. Second, we leverage these enriched representations to generate better product embeddings. Because our embeddings are now incorporate standardized attributes and categorical information, they capture deeper semantic relationships between products, improving similarity matching and recommendation. Third, and perhaps more interestingly, our canonical product representation with universal IDs um, allow us to identify multiple listings of the same product during search, which can boost the visibility for newer or smaller merchants who might otherwise struggle to surface their listings. The standardized attributes further enable more precise faceting, while our canonical representation improve query understanding and relevance. Now that I've covered the core components of the Catalog initiative, I will pass it over to Jonathan to explain how we train and serve these multimodal large language models.
So I'm going to go back from the multitask, multi-entity. So when we do those tasks, we basically take an image. We're going to have LLMs extract the information. But to be able to use those models, because we have such a huge amount of data, we actually need to fine-tune more models. We cannot just use OpenAI or Gemini. So what we're going to do is we're going to need to create data sets that we can use to fine-tune those models. And the datasets are going to basically be separated through those tasks. So each task will represent a dataset that we create and will follow the following pipeline. So basically, we'll take the product, we'll freeze it in time, and start create agents that we can use to basically create those datasets. So the agents are going to, for example, let's take the task of a category. We're going to have multiple agents that will try to find the category for the product. Those are the annotator. And now that sample can either become one of our test sample or one of the train. If it becomes the test sample, then we're going to show the suggestions that are coming from the LLM to a human annotator. And we're going to task them to decide which one is the best, or if they think that another category node should be the right one. Once we have those two annotations, we'll look at consensus and majority to decide that the sample, what is the category of the sample. And for the train set, it is too expensive to do the human arbitration on all of the data. So for the train set, what we decided to build is what we call this LLM arbitrator, which is basically performing the same task as the human. We're going to show them the suggestion coming from the agents, like multiple of them, to basically allow us to have a diverse understanding of the graph. Because one of the biggest complexity with the category is that the graph itself is pretty big, and there's multiple ways of traversing it. So we wanted to have multiple suggestions so that the arbitrator was able to see more of it when it's going to make his decision. And then the arbitration can decide either, okay, from the suggestion I can decide that this is the right one, or I'm going to abstain from answering, and then we will have to redo a pass with it. So just to show you a little bit what a human annotator would see, we'll see, for example, the product, the image, the description and everything. And on the right, we'll give him instruction and we'll tell them, okay, those are the categories that we got from the agents. And he can either select one of the three that you can see, or he can go at the bottom and basically say, no, this is none of those, and I'm going to search the graph myself to find the right one. So now that we have test sets, we can fine-tune models. So, okay, I'm showing an image here. So let's say we're with the media model that we're going to try to fine-tune. There's a lot of different tasks that we have. And that model is going to try to basically predict any of them. So what we found out is that when we started to do those kind of things, we would like always ask the model to do all of them when fine-tuning at once. But we actually found out that if we, during fine-tuning, we randomly pick the one that we want the model to extract, the model actually retains a better ability to answer questions after the fact. So the model retains a certain amount of generality that we didn't get when we were asking with a single prompt to extract everything. And so basically that is what we're trying to say here. Like when we fine-tune, we would like randomly tell the model to output exactly the fields that I want and not all of them at a time. And then when we want to evaluate those models, we evaluate them with 3 different metrics. We have task-specific metrics, like for the classification, for example, we have precision recall for this one at different level of the tree. And we can evaluate the model that way. When the task is a bit more generative, like for example, we have standardized title, standardized description, we cannot use classification metrics, so we're going to use judges to grade those fields. So the judges is going to basically have guidelines on what we want the standardized title and description to be, and we're going to ask him to rate the output of our models. And finally, we have the last type of metrics that we have on those models, which is the instruction metrics. So as I said, like with our models, we're asking them to output only the fields we want. So we need to be able to measure like if it's actually outputting those fields, which is the field compliance rate. So how much of the time is it actually outputting exactly what we asked for? And then the second one is what we call field invariance rate, which is, okay, let's say I ask for the category alone, and then I'm asking for category plus the title. Is the category going to stay the same? Because as you know, like those are probabilistic models. So it could be that when I ask for 2 fields at the same time, then the answer will change. So we wanted to make sure that the model would stay stable with that and would not start answering completely different answer depending on the field we were asking him. So that is what we measure here with that field invariance rate. So we're measuring the fact that the model stay consistent in the answer it's giving, regardless of the fields that we're asking for. Finally, to wrap all of this around like what we do for fine-tuning and training those models, we also basically try to have an active learning loop. So what we're going to do is that on the inference pipeline that we have that is running and doing around like 10 million prediction a day, we're going to have the judges look at those samples and basically evaluate the model. Like we said, like for the title, we have the guidelines, so we're going to evaluate if those titles are good or bad. And so what we can start doing with that is that we can look at the sample where the LLM judges is saying that the model is doing poorly, and we can basically try to take the sample, put them in the pipeline of creating trend sets for them. And the second type that we're doing with active learning is that we're looking at the probability of the output tokens to basically understand if the samples that we get have a high probability or a low probability regime. So basically, usually when the model is in low probability regime, it means that it's not really certain of the answer it's giving us. And this is where it's most likely to make mistakes. So what we want to do is we want to take those products and then also incorporate them into the trend set to make sure that we can have the model like always a response with as much certainty as it can. And finally, the last part I'm going to talk a bit about is, okay, we have those models now, they fine-tune, we evaluated them, how are we serving this? So the way it works is the client will be, for example, the admin. It's going to say, oh, I'm a merchant, I'm creating a product, I will put an image, I will put a title, I will put a description, and it's going to ask the model, okay, what is the category of that product that you just asked for? So the admin is going to send a request to the Triton server that is going to pre-process, then pre-process, call the LLM that is on the GPUs, get the answer, and then do a post-processing before answering back the client. And we have to do all of this because we have actually different places that can call those models. It's not just the admin. And we have really a huge amount of calls, like around like 10 millions a day. And we need to answer as fast as possible. And so one of the results we got with having this ability of only answering what we needed is that before we did those models, we were always answering like all of the outputs. But now, because we can really select only the one we need for each of the calls that we're making, we actually were able to cut down like the latency by a huge amount. So before we were like around like a median of 2 seconds to answer. And after the rollout of those models, we went to a median of 500 milliseconds and a P99 of 2 seconds. So we're most of the time answering in less than 2 seconds. And that also reduced a lot the GPU usage, because instead of outputting a huge amount of tokens, because we're outputting all of them, we only output what we need. And that's it for the implementation. So now I'm going to give the talk to Young, who is going to talk about the future implementation.
Thank you, Jonathan, for walkthrough and diving deep about the model training and inference. So for this section, I will be quickly talk about some downstream tasks and how we're using the catalog to apply it into several ML projects. So let's start with the search. So for search, like the unified catalogs can enhance the search capabilities by offering the detailed, like accurate and also standardized the data about the different entities, for example, the merchants, products, and the variants. So why it can be enhanced? To start, it can be improved like query matching in different level, for example, both in the token level and also in the semantic level as well, which can be resulting with more precise the searching result. Beyond that, actually, it can be also beyond that, it can be also increasing within the diversity of the search by incorporating the catalog data into the search re-ranking process, and which can be improve the long tail, like products and merchants coverage, as Andrews shared previously. Like we take an example. For example, if we just searching for something like the best local coffees in the Singapore, without just showing up the most popular brands, it can also showing up like very created list of the hidden gems from the local coffee shops that match their preference. Lastly, actually, the unified catalogs can be also allowed further refinement of the search results based on the user long-tailed preference and also the session interaction data as well, leading to the more engagement exploring process. Okay, cool. Beyond that, actually, as Ali mentioned previously, the catalog is also serve as the foundation of our commercial foundation models. Like we already show a lot of things about what is the commercial models, and I just want to give a brief talk about what is the foundation models at the model level. So basically, the foundation model utilizes the unified user interaction data, and it employs across various tasks, including, for example, personalized recommendation, like fraud detection or some like forecasting task as well. And this user interaction data is actually a multimodality sequential data. And it can be including some classic interaction data such as follow the merchant, purchase the product, or view the product, something like this one. But it also can be some like more rich information such as interaction via the search or the chat in our platform as well. So why the catalog data can be is really crucial in these cases. From the input side, like by incorporating the rich standardized data, we can enhance the semantic correlation between the different input modalities. And this will be significantly boost the performance when we're using or dealing with the multimodality data in here. Additionally, the catalogs can be also serve as a strong signal for some downstream tasks as well. For example, it can be used to improve the diversity for the recommendation task as well. And one last thing I want to quickly show is actually about the conversational commercial, which is actually available in our shop app as already. And in this case, it's when the catalog is pairing with the LLM, it can also boost the performance in here. For example, when we getting the when we getting the structured taxonomy data as the context in the LLM, then it can be improve the quality of the proactive suggestions and guidance through the conversations. For example, when in here, actually, the user is asking or curious about the gentle cleansers, and the LLM can respond with a suggestion reply like what is the type you are looking for, whether it is more sensitive or dry skins. And this can be mimic the experiments of the professional salespersons, and also can help the users to refine their choices during their purchase. And it can be also making it more engagement like shopping experience when we go to the next generation of the shop thing like commercial, the conversational commercial. Okay, so the last thing I want to quickly talk about is the challenge we have. In here, I will be mainly listing about the model challenge. And the first thing, actually, we all know that actually the catalogs has demonstrated a robust capability to extract the rich, standardized data and serve as a foundation for various downstream tasks. But we're still facing some important like challenging, and we want to solve it here. Like first, we want to we are still facing the ongoing challenge of balancing the scalability, the accuracy, and the latency. Like as we scale up our operations, we want to maintain the accuracy will ensure the quick response times is really important here as well. The second thing is that actually we want to consider about whether we can transit our models into the single model or single unified models. Currently, for each identity, we are actually still using the different models. The benefit for using the different models is because we can having the different model size across according to different tasks. And in this case, we can optimize for the latencies and also optimize for the accuracies as well. And this one will be actually leading an issue within the multi-modals, which means that when there are unbalance of the resources during the inference, it will be inefficient for the inference. And as long as if we go within the single model approach, it can be simplified the training and inference maintenance in here. But the question is that what should we do what is the best method in here? Like does the implicit MOE is the best method in here or what? We are still exploring about that. Last, actually, we want to also like when we check about the data, we can see that there still have correlations between the different identities. And in this context, we also want to using or leveraging the relationship to enhance the reasoning capabilities for our LLM approach through the graph-based methodologies as well. So, conclusion here. In here, actually, in this presentation, we presented the unified product catalogs in here, and this one can be standardized and connect products across a million of Shopify merchants in here. And also it can build in the knowledge graph of the product relationships, attributes, and also the metadata in here. Beyond that, actually, it can be enabled seamless product discoveries across the different shopping channels by improving by optimizing for the downstream task and serve as a foundation for there. So last but not least, actually we are in Shopify, we are on a mission of using the cutting edge algorithms to solving the real world problems. And it still have a lot of important research topic in here to explore, and it will be all settled down into the real world problems and settle down it into the meaningful production in our platform as well. So if you are interested or if you want to have more questions or want to dive in deep, definitely we are welcome to go to the booth and chat with our MLE as well. So we are in the booth E08. And also, if you are interested, you can also scan the QR code. That is the most important thing for my part. So to check about our open roles in there. So thank you so much for your attention, and I want to introduce back to my colleague for the Q&A sessions.
Great presentation, guys. You mentioned earlier that you were planning on evolving into a VR experience. So I was wondering, how are you guys integrating the geometry data and the hierarchical graphs of geometric data, aka the individual parts? So what work, if any, can you guys share on how you're taking documentation information from the product as a whole and resolving it down to individual components that may or may not be represented in the geometry? And as a second question, how are you guys thinking about dealing with poorly labeled geometry that corresponds to important components within the product?
So that's a great question. We should have highlighted more that VR is like a future application and that right now we're focusing more on AI agents. However, one of the ways in which we're starting to think about how we would um, adapt the catalog to support VR is exactly in predicting different size dimensions and understanding and like with the entity resolution layer, figuring out if we can apply something like AR, for instance, across more than one product. So I don't have the specifics you were asking for, but I hope that that helps answer a bit.
Yeah, it's a really pernicious problem. It's something that I'm pretty intimately familiar with because I've deployed similarly powered agents on Shopify with geometric data, and it was a real pain to get that resolved.
Guess maybe I'll add just
Yeah.
the one thing I'll add. I mean, no, totally appreciate it. Like the challenge that it will be there. I think like the important message, like with this journey, is even you can imagine with just the textual data, even just that you saw like how much work we had to put in with LLMs to be able to unify the product understanding. But the good thing is that that gives us like an opening, right? So now that we figured out how to unify with multimodality in terms of text and images, and that we were really reaping the benefits of that. I think that puts us in a good position to start going into like the more advanced topics, as you mentioned, like the more advanced problems. And yeah, if you have ideas, if you worked on that, I would definitely love to talk to you about it and see. Okay, cool. Awesome. Thank you.
Okay. Yeah. Can you go back the enhance the discovery slide? I have one question regarding your foundation model. Oh yeah, this slide. Can you give us more details about foundation model? Because just by looking at this slide, it seems that you have one foundation model to do retrieval, ranking, classification, and regression at the same time. But from my understanding that in production, we have lots of requirements on the latency. Can you explain more about this foundation model?
Yes, for sure. So for the foundation model part, actually, as you mentioned, the whole foundation model like block, actually it is shared between the different tasks, but the parameter will be updated based on the specific task as well. So consider about the latency stuff, like actually our model is running very efficiently based on the model-wise designs. So in here, like currently I'm not so sure, maybe we can share a little bit about the
Yeah, so the latency that we were discussing before is more on like the admin experience to be able to give a category and attributes. And it's actually not using that foundation model, that is using the model that we're fine-tuning. That is usually like a smaller architecture. Like we're actually using right now Quen 2, 3 billion and 9 billion. So, and the latency is more for that problematic because we're basically interacting with the merchant at the same time that he's fulfilling, like creating his products, and we don't want to slow them down. Because like if that experience is slow, then it's not engaging for the merchants to be able to create their products.
So you are using this foundation model in all tasks? Because I assume that for this foundation model, you have lots of parameters. Like you...
Because of our vocabulary size is very large, yes, we have lots of parameters, but we do a lot of like specific to the foundation model part. Like it is not as massive like parameters as other like huge LLMs. And also we do a lot of, as we mentioned previously, like it is still the single model for the multitasks as you mentioned, but it will be, the parameter is actually updated for the specific task, or at least the hand parameter will be updated as well. And I'm wondering, do you have this?
And also, like, how do you train this foundation model? Because you have so many tasks.
Yeah,
How do you ensure that when you are optimizing the retrieval, how do you ensure that it does not affect the performance of the ranking and the classification?
Actually, that's a good question. So basically, when we train the foundation models, it will be trained mainly using the next token prediction. So as you say, our input is a sequential data, which means that we are during the pre-training stages, we are mainly using the next token prediction as a loss in here. But when we're talking about the different tasks, for example, retrieval or ranking or re-ranking tasks in here, like for retrieval, we are still fine-tune the parameters of the models, and but it's loaded up from the pre-trained foundation models. And the data loss will be the contrastive learning, similar to the ranking part as well. Like for ranking, it will be multi-hand loss in there. Yeah.
Oh, so basically, like you have one foundation model, but for ranking, you will like fine tune based on this foundation model.
Yeah.
Oh, okay.
Yeah, cool.
Okay. Thanks.
Right. So
Be sure to check out our Expo talk from NeurIPS. I think it's available, where we talked more in more depth about the foundation model.
thank you. Thank you. My question was on your recommender systems. At this moment, some of your Chinese competitors, they're still very monoline. So if using your example, I buy an Adidas soccer ball, after that, I still get loads of recommendations of the same soccer ball at different prices. But what I really want is maybe the recommender system to diversify and show me soccer boots, and then socks, and then a jersey, and then shorts, which I can then buy as a whole set and then go and play soccer with the soccer ball that I bought. So are you guys dealing with the diversification of the recommender using LLMs with different temperatures, or are you still using human annotations to group them?
Yeah, that's a great question and a definite real challenge in production systems. Yeah, we're definitely looking into diversifying recommendation, and actually, thanks to the product catalog, we're able to tackle that problem head on. Like if we treated all the products independently, you can see how all that context would be lost. But now, as I said, like the message we want you to leave with is that this product catalog is like a foundation of foundations. Like all the recommendations work, the personalization work, that's all built on top of the unified product catalog. So that product catalog is already doing a lot of work to unify that information. We'll use that information in our product embeddings or product representation when we're training our recommendation foundation model. So we do that. We're looking into different techniques in terms of like diversity specifically. There's the typical things you can do in any production level recommender. Recommendation happens in multiple levels. Like you have retrieval, then re-ranking, and then after that you have like a level that focuses on diversification. So yeah, we're experimenting with different techniques that hopefully and putting in place different metrics that can allow us to serve diversified recommendations. Hopefully that answers your question.
I have a language. I have a question about language. How you work if one product, many languages, one product in English language, one product French language. Maybe you translate to one language. If product from two different countries, this is one product in your catalog or not?
So we have different abstraction layers for that. So we may have like a unified understanding of a product that is sold across different markets and under different languages, but then nothing stops us from then segmenting that for like the relevant markets or by language. So for instance, there's some standardizations that we do only across like a certain language, right? And without like necessarily in doing an intermediate through a translated language. And then in terms of like how we're handling language right now, it's also a little dependent on like how many markets our product is open to. But we provide like one of our future steps is providing many translations actually of a product to help with search specifically, so that users may search in a particular language and still manage to retrieve products that may be sold from different language merchants, but that are still available to be purchased from a certain region.
Hi. So in the last page of your slides, that it shows there's a KG. You will do a KG construction. So maybe I have two questions. The first thing is, you already have any KG now? And if you have, how do you use it? And the second question is the second last page of your slides. You say you will do some large language model reasoning on graph, and it's like a future work. Do you have any direction or insights of it? Yeah, large language model reasoning on graphs.
Yeah, so the insight here is like a big component of the system is graphs, like both like the taxonomy and how it interacts is like a graph. And then also when we're creating, like when we're performing entity resolution, that's also a graph-based operation. And what we're trying to stretch is like, how can we efficiently incorporate LLMs within these graph processes, but even like leverage classic like graph algorithms to help improve what we currently have. So, but like one interesting challenge is LLMs are very, very good at doing product matching. For example, like how could we incorporate that kind of insight within a graph structure that can be that are pretty large? So I hope that helps clarify some of that future direction. And if you work with graphs, please come talk to us actually.
Okay, thank you. I have actually two questions. First is about matching. You mentioned that you are building a product graph and then you cluster it to define unique product clusters. And different items in that cluster have different parameters. And usually on different marketplaces, the product data can be dirty, and it may happen that in some cases, like one product has a wrong parameter. Do you penalize merchants for wrong data?
No, so we still want to, like, we understand that at the end of the day, like, merchants leverage Shopify for different reasons and different use cases, and we really respect that. So we don't penalize them, but we might encourage them. And this is why we provide recommendations for product categories and attributes, like whatever insights we gain, we can feed that back to help make the merchant workflow as easy as possible and bring some of that standardization up front. But at the end of the day, like sometimes like it also tells us something about our platform and maybe where there's a lack of flexibility, so we can learn from that and adapt it and make it even better for merchants and their use cases.
Thank you. But imagine this case like someone is searching for a red dress on Shopify, and you have a merchant with a blue dress, but the merchant accidentally feel that this dress is red, so the user has like a list of dresses and one of them is blue, and this is really frustrating for the search team and search metrics.
Yeah, so when I say flexibility, like this is also for merchant storefront. Like merchants can also opt in to multi-channels or to be surfaced on a common search platform. In that case, like we will make sure that the information is correct. So basically, when you're shopping on a merchant storefront, shouldn't be a user impact. But when we're talking multi-channel, this is where the information has to be corrected, which I think maybe answers your question a little bit more.
Okay, thank you.
Yeah.
And another question about assistant platform. You mentioned you have a Sidekick, a merchant assistant. You have a Shop AI. I think it's like a buyer's assistant, and you said that there is a platform. So what other use cases for AI assistants do you have?
So, actually, we want to create the capabilities to enable like any AI agent, basically. So, even making this catalog accessible so that basically any agentic shopping can be improved and leverage corrected information.
Maybe one concrete, like other than the ones you mentioned, the Shop AI, the Sidekick, something that's available today for our merchants is kind of bridge between merchant and buyer, like the buyer bots that are available on shops. When a buyer asks a question, we have also solution built in house that generates answers automatically for the merchant. The merchant can review it before answering the buyer. That's
How much exploration have you guys done on the inferencing side of things? So yeah, I mean, a lot can be done from the model side of things, but I guess to juice out the last cortical juice of it, yeah, I mean, inferencing kind of becomes important, I guess. So just curious how much you guys have done there. I saw a graph where you mentioned you guys use TRT as a them. Has there been any explorations more on more inferencing toolkits, etc.?
So yeah, we have a team that is really working on like all of the inference side so that we get all of the juice that we can, and we're experimenting with other partners as well to help us like have the amount of GPUs that we also need, because as you know, with some of the problematic that we also have with those kind of systems is they take a good amount of GPUs and sometimes the availability is not necessarily there. So you cannot necessarily always scale up. That doesn't really work. So we have both people that helps us make sure that we have the GPU that we need, but also, and this is why we worked a lot around like this model that would only output what we needed, because we wanted to optimize the time it takes to answer. And we're also always looking at like when we're using a 9 billion model, we usually quantize it. So we do quantization. We also look at different framework of inference like VLLM, SGLang, to make sure that we can like squeeze as much as we can in that time to be as efficient as we can.
So currently you use TRT as a them, is it?
Huh?
Currently you use TRT as a them, is it?
No, so we use Triton to do the processor, the preprocessor and the post-processor, but actually the LLM that is on the side is using SGLang.
Okay.
Thank you so much, everyone. Thank you so much.